Hello students, welcome to the next class. In this particular session, we are going to look on a topic that is binary search in array in C programming. So in previous session, we have looked on the topic linear search. Linear search were basically searching an element in an array, traversing to the starting of array and going at the end. But binary search is much more efficient to look for an element inside the array. So what it does is it breaks and breaks and breaks an array into the parts of sub-array. Like a whole array is divided into half, then it again divided into half until the element is found. So the condition for this is for performing binary search inside an array, you have to be ready with unsorted array. That means when you are performing binary search inside an array, that array has to be a sorted array. That means it has to be properly arranged from ascending to descending or descending to ascending, any order you want. So let's start the program. So very first you need to include the standard input output stdio.h library. Second, you need to include stdlib, it is a standard library. After that, inside the main function, what you have to do is you need to declare certain variables of integer type. First is int a of size 10, let's say. Second is I for iteration of the loop. Element is a variable of integer type in which you are going to store a particular value that you need to look for. Next, low, another variable is high, and a mid variable also. These certain variables you need to have in order to perform binary search. And before performing binary search, you have to have variables to perform sorting operation inside an array. So for that, temporary variable and j for the secondary loop. First, you print the statement to the user, printf, enter the array. In this particular part of the program, you're going to input an array. For that, you need to run a loop from I equals to 0 to I is less than 10, and every iteration I is going to increase by 1. In this loop, you are going to read the element using scanf. %d is the format specifier for integer, and you're going to store that element at address of a of I. So now you have the array. The array is inputted successfully. You need to perform sorting operation on this array. So another variable we need to take is n variable. That is your choice, you can take or you can skip this, but I advise you to take it. In this variable, we are going to store the size of the array. So right now we have the size n equals to 10. So for the first loop for sorting operation, for I equals to 0, I is less than n minus 1, and every iteration I plus plus. Inside this loop, another loop will run. For j equals to 0, j is less than n minus 1 minus I. This is basically a bubble sort algorithm. At every iteration j plus plus. Inside this loop, you're going to look for adjacent elements, that if a of j is greater than a of j plus 1, then simply you need to swap those elements from one another. That is temp equals to a of j equals to a of j plus 1, a of j plus 1, and a of j plus 1 equals to temp variable. So simply in this part, sorting has been done. Now we have the sorted array, and after this we need to perform binary search operation on this array. So for binary search, you need to divide array into part of sub arrays. That means first you need to check few conditions. The very first condition is if, and before that you have variables that is low, high, mid. So what does mean that low is the lower bound that we have right now. Low is equals to 0 right now. High is the upper bound. High equals to 9, the maximum index it can hold, that is high is 9. And after this you'll ask user printf enter the element you need to search. Enter the element you need to search. Simply you'll read that element using scanf %d because of integer, address of ele, the variable you have taken, address of ele. I missed the double quotes over here, so double quotes, address of ele. After this you are ready to perform binary search operation on this. So after this what you have to do is simply you need to check if ele is less than a of certain variable will pass. So in this square bracket what we need to pass is a mid index. The mid index equals to mid equals to high plus low, that is higher bound and lower bound divided by 2. So if ele is less than a of mid, in this case what you will do, we'll see later on. We are simply leaving it like as it is. After this else if, inside else if part we'll check if ele is greater than a of mid. If ele is greater than a of mid, then what to do? We'll leave it as it is, we'll see later on. And at the end what we need to do is we're simply checking else if ele equals to a of mid directly. Else if ele equals to a of mid. In this case what you have to do is simply printf the element is found at %d location, or you can say index, and you can also write the variable the element %d is found at %d index, double quotes, and over here first is ele and second is mid, simply. And after that you'll just simply break this, and over here we are closing this section, this block of code. Now what happens if element is less than a of mid? That means element is not in the second half of the array, element is right there in the first half of the array, because it is less than a of mid of element. Like when you have a sorted array and you have the middle element, that means if your inputted element is less than that middle element, that means it is in first half of the array. So in that case what you need to do is you simply change the high variable, that is high equals to mid minus 1, simply high equals to mid minus 1. In second case, if element is greater than middle element, that means it is inside the second half of the array. That means simply what you have to do is you simply increase the low variable. Low equals to mid plus 1 in that case, simply. Now you are ready to perform this, and that means your algorithm is ready right now. But how many times you need to repeat this? That means till how many times you need to repeat this block of code. Till how many times? That means until, like that means while low is less than high. While low is less than high. Inside this you also need to write inside this you also need to write mid equals to high plus low divided by 2 every time. Mid equals to high plus low divided by 2 at every iteration, and give a tab space to whole of this section of code. So we have the section of while loop. It will repeat until low is less than high, and after this main function ends over here. And right now we are saving this, and also write the element percentage is found at percentage d index after performing sorting operation in increasing order. Save it, go to the files, open in terminal. File name is bsearch.c. Open in terminal. After this you can simply write gcc file name is bsearch.c-o. let's say bsearch, I'm giving the file name, /bsearch to run this. Enter the array. I'm inputting random array right now, 14, 15, 17, 18, 10, 15, again 12, 9, 8, 14. Enter the element you need to search. For example, I need to search and look for element number 9. So after sorting operation, 9 will come at first index. So it should give me the answer 9 is found at index number 1. So the element 9 is found at first index after performing sorting operation in increasing order. And also, if it is not there, you can simply write inside the else part, that is also that will come on later on. The else part we'll see later on. After performing sorting operation, you should also present the array to the user. Now the array looks like this. So printf the array after performing sorting operation looks like this. The array after performing sorting operation looks like this, and you'll simply write the array for I equals to 0, I is less than 10, I plus plus, inside this printf percentage d a of I. So it will make things very clear for the user as well. So now we should run this again. gcc file name.c, that means bsearch.c-o bsearch1. Okay, what is this expected declaration? Okay, there is something error 58. I forgot to close this loop, curly braces. We should also remember these type of mistakes. Those mistakes are very normal. gcc bsearch.c-o bsearch1 /bsearch1. Hit enter. Enter the array. That means I can enter anything. 17, 8, 17, 18, 15, 65, 82, 100, 144, 89, 58, 75. So the array after performing sorting operation looks like this. So it has arranged the array in increasing order. Now it is asking me enter the element you need to search. Let's see, I want to look for element 89. Hit enter. The element 89 is found at 7 index after performing sorting operation in increasing order. So it is there right there at location number 7. Right. So what if element does not exist? What if element is not there? What need to do that? What we need to do then? Okay, that means we can take a variable known as found variable. We are marking that 1, and simply we are changing over here. We're declaring with 0, found equals to 0, and at the end we are simply checking after the while loop. After the while loop, we are simply checking if found equals to 0. If found equals to 0, that means printf element does not exist in this array. Element does not exist in this array. So user will be very clear. So this is a generalized program to perform binary search inside the array. Let's clear all this. Again, GCC file name is bsearch.c -o bsearch2 /bsearch2. Hit enter the array. 78, 54, 65, 25, 15, 58, 95, 63, 14, 100. So array after performing sorting operation looks like this. Let's say I'm inputting an element that does not exist in this array. Let's say I'm looking for element 10 and 10 is not here. So it is not giving me any answer. Why? Because it is not giving me any answer. Why? We missed the assignment operator. So it has to be equals to 0. These kinds of mistakes are very common. So you just need to be very careful about this. When you're making a code and you're making in a very fast way inside the practical exam or in a theory exam, so what happens is you miss a comma, you miss a semicolon, you miss a comparison operator. So again we'll run this. GCC file name is bsearch.c -o and bsearch2 /bsearch2. Enter the array. 14, 75, 82, 95, 41, 12, 32, 78, 100, 105. So array after performing sorting operations looks like this, and is asking me to enter the element I need to search. Let's say I'm inputting the element 10. Element does not exist in this array. So 10 does not exist in this array. Simply. So this is a basic program and a generalized program to perform binary search operation in an array using sorting as well as using bubble sort as well as the binary search. That is a very simple and understandable algorithm. So this is how we perform binary search in an array. That's all for today, and we'll meet very soon in the next class. Thank you very much. Have a good day.